welcome. So now we're going to do a few more problems. All right, so we have number 14, the integral of t divided by the square root of 7 minus t squared dt. I did rewrite that for us. All right, so we have a negative exponent, or a radical in the denominator. I rewrote that as a negative exponent. All right, so now let's identify. This is a u to u substitution that will be needed to integrate. So u should be the thing that's raised to a power, which is 7 minus t squared. All right, so the derivative du equals the derivative of negative t squared would be negative 2t. Right, and I'll move the dt here automatically. And now I see a t, but I do not see a negative 2. So we have a constant that, or a coefficient that we can't account for, but that's okay. Just divide both sides by the coefficient, and that means negative 1/2 du will represent dt. Right, so excuse me, dt. So let's write that nicer. Right, so this part here, not the exponent, but the rest, the t and the dt, will be represented by negative 1/2 du, and then the 7 minus t squared will be represented with the u, and the exponent stays. So now we'll rewrite this. So this will be the integral of u to the negative 1/2. Oh, don't forget the negative 1/2 in front, right? So negative 1/2 integral of u to the negative 1/2 du will integrate. All right, so we're going to increase the exponent by 1, divide by the same thing. All right, so negative 1/2 plus 1 would be positive 1/2. So this will be u to the 1/2 divided by 1/2 plus c. Let's simplify that. So dividing by half is the same as multiplying by 2. So that would be 2 times negative 1/2 u to the 1/2 plus c. Right? And the 2 and the negative 2 and the 1/2 cancel each other out, leaving just the negative. And at this point, why don't we replace the u and rewrite our equation, the antiderivative. Right? So f of x equals negative, and I'm going to write it as a square root of 7 minus t squared plus c. There we go. Right? Sorry about the little blip there in the radical there. All right, so that one is done. Number 15. So we have a fraction here, and well, it's not in the form of arctan, and it's not in the form of natural log, and so the denominator has the larger degree, so I can't just divide by the denominator and change this. If you have a fraction and the denominator has the greater power and it doesn't match any other pattern, try splitting the fraction. All right, so we can just split this into two fractions, and maybe we can integrate them separately. All right, so this will be the integral of 3x divided by x squared plus 4 dx plus 2, actually I'll leave it in there for now, and then I'll take them out. The integral of 2 times x squared plus 4 dx. So as I was about to start to do, let's factor out the coefficients. We can factor out the 3 and the 2. So 3 times the integral of x over x squared plus 4 dx plus 2 times the integral of 1 over x squared plus 4 dx. The first one needs a u to u substitution. The second one, I hope you notice what it is. We can integrate that directly. That's one of the reasons I factored out the 2, so you could see right away what to do. All right, but for the one we need the u to u substitution, u is going to be the denominator on that first fraction there. X squared plus 4 du will be 2x dx. We don't have a 2, but we have everything else, so that's okay. Divide both sides by 2, so 1/2 du equals x dx. All right, so the 3 stands. We're going to represent the x dx part. So all of this right, is going to be represented by 1/2 du, and the denominator is going to be represented with u. Right, so, and we're going to factor the 1/2 out right away. So that's going to give us 3 times 1/2 will be 3/2 times the integral of du over u plus 2 times the integral of 1 over x squared. I'm going to rewrite that 4 as 2 squared dx. And now you see what it is. All right, that's arctan. And the variable is just x, and the a is 2. All right, so now let's integrate. All right, so du over u, all right, that is natural log. So we have 3/2 natural log absolute value of u plus 2 times, so 2 divided by 2, right? So we divide, so normally it's 1 over a, and a is 2, but there's already a 2 there, so now it's 2 over 2, which is going to cancel each other out. And then this is arctan, and then of x over 2 plus c. And now let's just substitute back for u, so u is x squared plus 4. So 3/2 natural log of x squared plus 4. I'll leave the absolute value bars in, even though there's no way that could be negative. Plus 7/2 arctan x over 2 plus c. Oh, and I forgot to write f of x. You know what? I'll put it in red. I've been putting the final equations in red anyway. And I forgot the f of x. So I'll just write it again rather than have to, I don't know where I'm going to fit it if I don't. F of x equals 3/2 natural log of x squared plus 4 plus the 2/2, I'm sorry, that's a 2/2. Can't read my writing. And that will reduce to 1, so arctan x over 2 plus c. So if I put in a 7/2 before, that was just because I can't read my handwriting. There we go. Now I can read it. And there we go. See? So what looked like it was going to be really hard once we split it was really easy. All right, let's try the next one. Now this is one I wrote myself, and I'm hoping, my only concern is the limits of integration. But I wanted to pick nice values that worked with the function and nothing outside the domain of the function, which was a problem if you're trying to take a definite integral. All right, so I'm going to rewrite that as the integral of from the square root of 2 over 8 to 1/4 and dx over the square root of 1 minus 4x all squared. And I hope you see which type of integral this is going to be, what rule we're going to use. We do need a u to u substitution. U is going to be 4x, right, in the parentheses, because everything else is good. Du would be 1/4 dx. I do not see a 1/4, so we'll multiply both sides. Well, not 1/4, excuse me. 4 dx. I am thinking of the next answer because we'll have a 1/4. 4 dx. The derivative of 4x is 4. We're going to divide both sides by 4. I'm thinking way too far ahead. 1/4 du equals dx. I was already thinking of what's going to be the du. All right, so we will replace the dx with a 1/4 du. And we will replace the 4x there with a u. All right, and this is a definite integral. And rather than having to substitute back, let's find our limits of, let's change the limits of integration. All right, so this is the lower limit. If x equals square root of 2/8, then u equals 4 times the square root of 2/8, which is the square root of 2 over 2. And then upper, if x equals 1/4, then u equals 4 times 1/4, which is 1. All right, so now let's go ahead and rewrite this with the substitution. So we have the new limits are going to be the square root of 2 over 2 to 1. And now this is, don't forget the 1/4 there. We'll squeeze that in. Oh, we could write that a little better. I started to write the limits and I hadn't written the 1/4 yet. There we go. So square root of 2 over 2 and 1. And then this would be du over the square root of 1 minus u squared. And of course, this is arcsine. All right, so we have 1/4. And so this is going to be arcsine. Right? And the our variable is just the u, right? It's this right there, divided by our a. But a is 1, so we don't need that. And we're evaluating that from the square root of 2 over 2 to 1. So now let's substitute. So we have, and I'm going to distribute the 1/4 at the end. So we have arcsine of 1 minus arcsine of the square root of 2 over 2. All right, and so what this is saying is, where is arcsine 1? Excuse me, where is sine 1? Arcsine's not 1. It's saying, where's sine 1? All right, so we're taking the arcsine of 1. Well, sine is 1 right here at pi halves. All right, so we have 1/4 times pi halves. And where is arcsine equal to square root of 2 over 2? All right, well, that's the first quadrant. All right, and this is the 45, 45, 90 triangle, right? 1, 1, square root of 2, and so that is pi fourths. Not written very neatly, but pi fourths. So minus pi fourths. All right, so you just got to squeeze this in here. Actually, nobody says I can't do that. There we go. I need more space here. So all I've got to do now is simplify. Pi halves minus pi fourths is pi fourths. So 1/4 times pi fourths is pi 16ths. That would be the area under that curve. All right. 16's done. That's 2 to 17. And I think that one's been rewritten in your notes. In your notes, it was just, it wasn't a definite integral. It was an indefinite integral. So I changed it. Needed a little bit more practice. All right, this one, we do have a tiny little u to u substitution. Why don't we break that up into 2? All right, so this is equal to e to the negative x dx minus the integral of 4x dx. Don't need a u to u substitution on the second one. That's an easy one. The first one, a tiny, itty bitty substitution. U is negative x. Right? It is the exponent on e, because it's not just an x. So du will be negative dx. Don't see a negative, so negative du equals dx. So the e stays, right? The negative x is now a u, and the dx is now a negative du, and we're all good. So let's rewrite this. I'll rewrite it over here. So we have the integral, and I won't do anything with the second part yet. I'll just take the integral all at one time. So we have negative e to the u du minus 4x dx. So now we can just integrate. So this is going to be, I like to switch colors here, negative e to the u. So easy. Right? It's its own derivative, its own integral. It's everything to itself, right? Minus 4x, just undoing the power rule, 4x squared divided by 2 plus c. Right? And so now let's substitute back so we don't have two different variables, and let's reduce. So f of x equals negative e to the negative x minus 2x squared plus c. And that one is done. And we're on to the next one. Right, so if you have a fraction with one term in the denominator, divide the terms in the numerator by the denominator. All right, don't sit there and go, what do I do? I can't do anything with that. You're right, in that format you can't do a thing with it. But you've only got one value, so you can divide each term. It wouldn't matter what that term was, really. You should try splitting it up, right? But that's e to the x. That's going to be an easy one. All right, so we're just going to divide e to the 2x divided, but actually I'll write this separately. So e to the 2x divided by e to the x dx minus, just so I make sure everybody sees what we're doing, e to the 4x divided by e to the x dx. Squeeze that in there. All right, so now, all right, everybody move over just a little bit. Okay, all right, so now when we reduce, when you divide like bases raised to a power, you subtract the exponents. 2x minus x is x. So now this is the integral of e to the x dx minus 4x minus x is 3x. Now this one needs a teeny tiny, itsy bitsy, a little itty bitty u to u substitution. U is 3x, du is 3 dx. Don't see a 3, so 1/3 du equals dx. All right, so in that one we're going to replace the 3 to the x, 3x with a u. We'll replace dx with a 1/3 du, and e stays. All right, so now let's integrate, and then we'll write our final answer. So we have, now I'm just going to leave this one because I gotta substitute first. And then we'll just do them both at the same time. So this is going to be 1/3 e to the u du. All right, so now we've got, I got so into making integrals, I'm going to make another integral. All right, so this is going to be just e to the x. So easy. All right, and this will be minus 1/3 e to the u plus c. The only thing we have to do is substitute back, move that over there, for the u. We're going to put the 3x back. So our final answer is f of x equals e to the x minus 1/3 e to the 3x plus c. And you can see if you took that derivative of the 1/3 e to the 3x plus c, right? 3x times 1/3 is 1, right? And that's where your coefficient went, right? So there we go. That looks pretty icky. I'm going to make a nicer C. And then we're going to move on to the next question. So far, I'm going to keep on going. I might break this up, but there isn't that many left. All right, so this one is number 20. All right, let's take a look at that one. All right, so you know what? I'm going to save 20 for a little bit. Let's do 20 and 21. All right, I'm going to come back and do 20. Because I feel like waiting on that one. Yeah, we'll wait on that one. And let's do 20. I don't know what number this is. The one with no number. Let's do this one first. All right, so we have the integral of 0, a natural log of 2, negative natural log of 2. I guess that's a negative there. To 0 of e dx over 1 plus e to the 2x. And so let's see, what should we have here? I think something is missing off of this. Well, I'm going to change it anyway. I'm going to wait on the top two, just because I don't know if I miswrote it, because something is missing that we can't take care of. I believe something is missing. So I'm going to check those two, and let's go on to 21. Yes, 21. Because I'm probably going to have to do this in 2 tapes anyway, just so it doesn't get too much over 30 minutes. So u here, this was going to be u to u substitution. U is e to the x, and du, of course, is e to the x dx. All right, so we have everything we need, right? So this will be replaced with the u, and this will be replaced with the du, and the e to the x stays. So this is the integral of cosine u du. We integrate. Whose derivative? You know what? I'm all cramped down here. I got plenty of space. Whose derivative is cosine? Why, it's sine. So this is going to be sine u plus c. Let's substitute back, and we're done. So f of x equals sine e to the x plus c. And that's all there is to that one. That one's nice, easy one. All right, we have a random 1/4 here. I'm going to assume that that doesn't go anywhere. Sometimes when I was moving things around, I don't think that's supposed to go anywhere. How to move pages. I wonder if that is one of my missing values someplace else. Anyway, let's do this one. 9 minus 6d, the integral of dx over the square root of 9 minus 16x squared. I want to rewrite that first. All right, so dx over the square root of 3 squared minus 4x squared. And I hope you know what this one is. U is going to, we haven't had any so far with arcsecant. Maybe I should change one of those ones that I'm going to come back and do as arcsecant. I haven't seen any arcsecants. All right, so u is, maybe there was one earlier. Anyway, u is going to be 4x, and the derivative of that would be 4 dx, and there's no 4 dx, so 1/4 du equals dx. So that 1/4 was probably something I forgot to erase. All right, and so now let's rewrite this one. We have 1/4 du over the square root of 3 squared minus 4x squared. All right, so when we rewrite, this is going to be arcsine, right? And the 4x is going to be the u part, the part in the numerator of what we're taking the arcsine of, and the a is the 3. Right? It's our thing. 1/4 arcsine, and that will be 4x divided by 3. Oh, excuse me. Not yet. I didn't substitute. I'm sorry. Well, I'm thinking ahead. I didn't substitute back here either. U squared. All right, now let's integrate. Now that we have u's that match du, this would be 1/4 arcsine u over 3 and plus c. And then let's replace, at this point, we will replace the u, not before. And then we have our equation. So f of x equals 1/4, oops, I said arcsine, but where's the arc part? I don't know. 1/4 arcsine, and it's 4x over 3 plus c. There we go, another one done. All right, so let's take a look at 23. This is a u to u substitution. U is going to be x cubed plus 2. Du is 3x squared. Dx, we are missing the 3. That's okay. We'll divide by 3. So 1/3 du equals x squared dx. All right, so now let's rewrite this. So we have 1/3 times the integral of du is in the numerator, and u is in the denominator. And hopefully you recognize this right away. That's natural log, right? So remember, when we take the derivative of natural log, the thing that we're taking the natural log of goes to the denominator, and its derivative goes to the numerator. And so that's what this one is. So nice easy integration here. This would be 1/3 natural log u plus c. And then let's just replace the u, which is x cubed plus 2. So 1/3, f of x equals. Right, so we have f of x equals 1/3 natural log of x cubed plus 2 plus c. Right? And then next one here, try rewrite when you have one trig function and none of its nothing to go with it. Right? So sine, cosine, that's easy. But a cotangent, what do we do with a cotangent? Let's rewrite it using a trig identity. All right, so we're going to rewrite this as cosine x over sine x dx. And now we would be able to integrate this now. Because now that we've rewritten it, we've got the parts we need for u to u substitution. You couldn't do anything with cotangent x. U is equal to, it's got to be the denominator. Because otherwise, there's no way you can get anybody in the denominator. Unless it's u. So u equals sine x. That makes du equal to cosine x dx. Everybody is represented. All right, so we have the integral of du over u. Well, we know this one, right? That's just going to be natural log, actually I'll write that below. Natural log u plus c, like we'd see right above us. And now all we have to do is substitute f of x equals natural log of sine x plus c. So you probably wouldn't have got that one, right? Unless we rewrote it. And once we wrote it, it's not too bad at all. I'm going to end the tape here. I've got 3 problems left for the next video. All right? See you later.